Hello, everyone. Thank you for coming to the Let's Build on Google Cloud on FHIR. So today, the format of this is going to be that I'll give a brief talk overview of what we're going to be doing, what we're going to be building, but the majority of the time, this is a double session, will be for you to work through the lab. So this lab will be open for 2 weeks after this presentation. So if you didn't get through it in the time, or you want to show it to one of your colleagues, you can still access this lab until the end of November. So to introduce myself, my name is Nick. I am a software engineer on the healthcare API at Google. And my colleagues, Patrick and Frank, will be helping me out. So if you need help at any point during this lab, please put up your hand and we'll come to you as quickly as possible. So what are we going to be doing exactly? We're going to be building a prediction pipeline using FHIR as the data format on the Cloud Healthcare API and using Google's AI platform. So this is going to be run in the Quick Labs environment, so it gives you free access to all the tools that we're going to be using through the use of a student account. It's a self-paced lab, so you can go through the steps as quickly or slowly as you want. We're going to be using the Healthcare API, which includes FHIR, but also has DICOM, HL7, all of the data formats supported by Google Cloud. And the model we're using is just a simple example model built on TensorFlow. None of this is clinical data. None of this is a clinical quality model. Instead, it's just supposed to be simple to understand, easy to deploy and train for example purposes. So once you have trained your model, you'll be serving predictions from the AI platform using Cloud Functions. So a few pro tips before we start, just to make sure that we have as few errors as possible. When you hover over these code snippets, you'll see this little copy button. If you click this, it'll automatically copy everything in that code block. So this avoids you potentially missing a few characters at the beginning or the end. But yes, it will only appear when you hover over the actual code block. The other thing, and we apologize for any difficulties that this may cause, the AI platform takes a while to deploy your model once you get to that step. And you'll see that there's this done column. And the done column is the name, and it doesn't mean that it's done yet. So you need to wait for it to say true in the done column. That confuses everyone, it confuses me, so just keep that in mind. It needs to say true in the column. So this is where we're going to be going to create your Quick Labs account. If you were in my colleague Sasha's session yesterday, you will have already created an account on explore.quicklabs.com, but if you haven't, please start doing that now. This is not the same as quicklabs.com. That is our public Quick Labs. So you have to go to explore.quicklabs.com, create an account there. Once you have that account, I'm going to leave this slide up for a little bit, but the links will remain on my slides for the rest of this presentation. Once you've created your account, please go to this tiny URL, and that will link you to the Google form you see here. You can also scan the QR code if that's easy for you. Put the same email in to the form that you did when you signed up for your Quick Labs account, and that will allow us to add you to the classroom. So you're not going to get an email or anything. We'll be manually adding you to the classroom as we get responses from that form. Okay. So I'm going to walk through a bit of the lab while everybody's registering and kind of walk you through in more detail the steps that we're going to be going through. So we're using TensorFlow to do our predictions, and so we need to go from FHIR resources to TensorFlow. So part of the scripts in this lab is to convert FHIR resources to TensorFlow records. And so if you're going to be doing predictions like this yourself, you have to do that feature extraction from your FHIR resources to something that TensorFlow can understand. As I said before, this is not a clinical model. None of this data is clinical. It's all just for example purposes. So the healthcare API is more than just FHIR, as I said before. We're using various industry standards for healthcare data so that you can bring those pieces together and do insights on them. So we support DICOM, HL7, and FHIR. We also have the tools to do cloud ML and run various machine learning and analysis pipelines. So this gives you your bridge into analytics through the FHIR store. We export to other tools such as PubSub to trigger this analysis and BigQuery to actually do your data analytics and exploration of your data. So how do we go about building that data pipeline? We start with discovery. So in this case, we are building a model that will predict lung cancer risk based on just a few features. So we start with Cynthia data. So all of the patient information that we're using today has been generated with Cynthia. We extract the age, weight, and if the patient has a history of smoking. And then we output the probability of lung cancer later in life. So our input tensor is just the three values you see here. To do our training, we write those TensorFlow records into cloud storage with one script, and then another script will process those, pull them down, train our linear classifier on that data, and then create the model that we need. And once the model has been created, we deploy it onto CloudML, or the ML engine. So what this does is it allows you to make a simple REST call to your engine to do prediction. So you don't have to invoke your model or anything. It's all handled just through one API call. And then we actually want to put this in sort of a pseudo clinical workflow. So what's going to happen is we will write a patient and an observation into the FHIR store. The FHIR store is configured with PubSub notifications. So this will get triggered every time a new resource comes into the FHIR store or gets updated. Cloud PubSub then triggers a function, which is a small Python script that will get the data we need, invoke the model, and then write the data back into the FHIR store. So we're using patient everything to take the patient that has been modified, get all the observations we need to discover that history of smoking, and then build our input tensor. So the cloud function, after it retrieves that data, writes to the ML engine or requests that the ML engine do a prediction. And then once we have that information, we will create a risk assessment which has that risk of lung cancer. So all the code is hosted on github.com, and you'll be cloning this repo as part of the lab, but obviously you can access this whenever you want, and all the instructions included in the Quick Lab are also part of the repo. So you don't have to do this in the Quick Lab's environment, but you'll be paying for the resources you use if you do it that way. Okay, so if everyone is ready, the links are still here, and we'll be helping you get started if you have any questions.